Our last example that we're going to look at is the closest approach. So when we've got two velocity vectors out in space and they don't collide, so we're looking to see when they do actually get to their closest position to one another. So we've got Snoopy and the Red Baron. So hopefully you can have that lovely picture of Snoopy cruising around in his little airplane. And we've got all the information of their position and their velocities. And we want to know the closest they come to each other. So let's do a quick sketch of what we know. So in our 3D axes, we've got Snoopy's position and his velocity. We've got the Baron's position and his velocity. We know we can look at the original distance from Snoopy to the Baron, and we know that we can combine the two velocity vectors. So we're going to stop Snoopy by taking that away, and we can see that the velocity resultant is going to be this green line here. So obviously velocities come in multiples, and so we can see that the velocity vector is heading in this direction. And so the closest point again is always the perpendicular. So this point C is going to be the closest. If Snoopy stands still, the Baron is travelling towards him, this is going to be the closest distance. So what does this look like using our calculations? So again, we're going to do two methods. So just like in the previous video, we're going to look at the dot product and we're going to look at the cross product. So let's do dot product first. So like we said, we're stopping Snoopy and then seeing how close B gets when it's travelling on that new velocity relative to Snoopy. So we're just focusing on that bit there. So that's Snoopy, his original position, that's the Baron, his original position, and we've worked out the resultant velocity vector is going to be travelling along, and we're looking for that shortest distance. And again, we know that that shortest distance, SC, is going to be perpendicular to BC. So SB we can work out. Hopefully you've got the information from the previous page written down, so you can follow through and agree with me. So we've got 5, 18, 52, blah, blah, gives us the resulting of SB. So that's just that purple line. Then we've got that resulting vector. So B's velocity relative to S. So S is still and B is travelling. B, it seems as if, is travelling towards S. Okay, so that would be our resulting velocity. Remember when we did this with 2D vectors a while ago, if they were going to collide, then this velocity would be a multiple of SB, because then it wouldn't actually be on the green line, it would be on the purple line and they would actually hit. But because we can see that's not a multiple, then it's not going to be a collision, it's going to be out here somewhere. Alright, so now we want SC. So we've got SB plus BC is going to give us our SC. Throw in what we know and simplify. Obviously guys, I'm just trying to save space in a PowerPoint. Try, if you can, maybe to use vertical vectors when you're writing in your notes, just so it's a little bit clearer what it is that we actually have, especially when you start doing the scalar multiples of the velocity as well, it gets a bit messy. Alright, keep working through. So we know our perpendicular is going to be SC dot 0 to negative 1 equals 0. So put all that information in, simplify, and we get that it's going to be at t equals 2. So they are closest after 1 second. Put that back into our SC, and we get that the magnitude of SC is going to be the square root of 470. And if we wanted to know where each was at this position, so where is Snoopy and where is the Red Baron, so if we put t into where Snoopy is, t into where Red Baron is, those are their position vectors at t equals 1, and that was the distance that they are apart. All right, same question, but now we're using the cross product. So again, we're doing the same logic. We're going to stop Snoopy and see how close B gets to S. So same information we had before. So B's velocity relative to S. And again, we've got that same diagram, but now because we're using the cross product, we need to picture the perpendicular as well as that point. So B relative to S is going to be that starting position plus some multiple. So the barren starting position plus some multiple. So that diagram we looked at originally. Again, we know C is going to be the perpendicular, the closest point, and D is just any point along that journey that the barren is travelling. All right, put in what we know. So BD, we know because it's the direction, is 0 to -1. OD, we can work out by subtracting B, would give us 5, 20, 51. And SD is going to be that again. So once we know OD and S, we can find SD. All right, so obviously I'm not going to go through the steps of the vectors. So if you're not sure of any of these, let me know and I'll go through them a bit more slowly. But we've been doing this for a while, so I'll just save some time going through the explanation. All right, again, from the previous video, we got this formula. So I'm not going to go through the steps of the formula again. Go back and watch the previous video if you're not sure where this came from. Now, this notation here is if we would throw it straight into the class pad. So I'm going to do that in a second. I'll just finish the slide. All right, so I'm going to jump across to the class pad. Now, hopefully you can see this okay. Get my windows right. Okay, so hopefully you can see this okay. So I'm just going to show you this part here in case that's unfamiliar to you. So I'm just in main. I'm just going to do a clear all so you can see what's going on. All right, now remember we go into our action vector, and remember we talked about there's these options here. So normal will actually find the magnitude for us. So to save ourselves a bit of time, because a question like this we probably would be doing in a calculator, I'm going to bring up my keyboard, add my matrix. So we know we want to do the cross product, so I'm going to do the action. I'm going to try and do it all in one go. So I'm going to do the normal of the cross product, don't forget to throw a comma in there, of these two bits of information. So BD is 0 to -1. And what have we got? SD was -15, 7, 14. All right, so that's done the cross product of those two things first, which is what we wanted. And then it's found the normal, which is just the magnitude. Same thing, I want to find the normal of BD, so let's save ourselves a bit of time, just drag that down. And BD was just our 0 to -1, and then we're just dividing the two. You can see we get the same answer. Okay, so just remember that's there just to save ourselves a bit of time. All right, rather than starting at the slideshow again, I'll just go to that last page. So like I said, remember guys that there are e-activities for you to look at. We looked at closest approach before when we were doing 2D, so make sure you go back and have a look at those. And now that's everything that you need to finish chapter 5. So there's a 5E exercise, which is incredibly short, but there's an extra exercise on exercise 7.5 that I would like you to do again. All right, thanks and good luck.